Welcome to Morphic Labs, and today we are going to be talking about imbalance bars and Garmin class volatility bars. But before we get into that, do me a favor, hit the subscribe button if you want to keep up with more content like this. And if you're interested in getting your hands on this advanced aggregation course and this market microstructure and trading systems course, the links in the description. It's basically free. You just have to sign up for a free membership and you have it all to yourself. Now, let's get into it. And we are at information driven aggregation, finally. Now, what is an imbalance bar? Imbalance bars close when the imbalance between buyer and seller aggression exceeds a threshold, capturing information arrival. Here's the formula. Tick rule is defined as B sub t equals 1 if delta p sub t is greater than 0. Negative 1 if delta p sub t is less than 0. B sub t minus 1 if delta p sub t equals 0. The cumulative imbalance is defined as theta sub t equals the sum of B sub t times V sub t, where V sub t is our prior volume variable that we used in one of our other aggregations from t equals 1 up until t. The bar close condition is defined as the absolute value of theta sub t is greater than or equal than some threshold. Now, when do you use this type of aggregation? High frequency microstructure analysis, detecting informed trading, order flow toxicity monitoring, market making strategy development. Now, what are the advantages of this type of aggregation? Directly captures information arrival, more uniform information content per bar, better for microstructure research, adapts to changing market conditions. Now, what are the disadvantages of this type of aggregation? Requires tick level data with direction flags, more complex implementation, threshold selection is non-trivial, computationally intensive. Now, let's get into the code. Here's my aggregator. I'm not gonna get into that right now. Now let's start with a threshold of 1 with the first 100 indices from my Bitcoin 1 minute data. Now, as you can see, we have raw price bar close when the imbalance is met and aggregated closes. Now, our threshold is 1 right now. And as you can see, our aggregator is essentially closing fairly enough. But let's see what happens when we try to make the aggregation bigger. Let's say 1.5. Will there be a noticeable difference? Okay, let me plot them side by side actually. Wait, this the wrong frame. Okay, I think this frame is better. Okay, let me just change this then. Now, if you pay attention, you can see the one with a smaller threshold seems to have more bars, but let me make it even smaller. 0.1. Just plot these together. And essentially, as you decrease the threshold, the number of imbalances that get met increases. Now, let's try this for more indexes of the data set. Now let's try numbers. Let's try 2.5. We're gonna try 0.001. And as you can see, the threshold that's smaller has more closes, and the one that's bigger has less closes, right? Now let's extend this to 1,000 entries. As you can see, for a threshold of 0.001, the distribution of bars is nearly, if not uniformly distributed. But when you look at a threshold of 2.5, it seems like the distribution has some sort of pattern there. Now, I'm going to just be looking at a threshold of 2.5 or play around that range. Let me just increase the number of entries to 5,000. Wait, how many entries are even in this data set? Okay. Isn't that beautiful? You can see all the periods where the imbalance was met and it wasn't met. Now I want to play around with this variable. I want to see if I take it to 2.8 how it would look. Probably a difference that my eyes can notice. Let me try something bigger. Now I can see something. Let me push it up to 7,000 entries. I'm gonna keep it at 10.5. Okay. Let me go back to our first number 2.5. 2.5 still allows for structure. You can see the periods of no imbalance being met and periods of imbalance being met. It's very beautiful. Now that's about it for the imbalance bar. Let's get into Garmin volatility bars. Now, what is a Garmin class volatility bar? Garmin class volatility bars uses the Garmin class estimator, which is approximately 8 times more efficient than the standard close-to-close estimator. The formula: Garmin class estimator is defined as sigma sub jk squared equals 1 over 2 times the natural log of h over l squared difference 2 times the natural log of 2 minus 1 times the natural log of c over o squared, where h is defined as high price, l is defined as low price, o is defined as open price, and c is defined as close price. Our bar close condition is the sum of sigma sub jk squared from bars up until some arbitrary value is greater than or equal than sigma sub target squared. Now, when do you use this type of aggregation? High precision volatility estimation, intraday volatility strategies, options market making, variance swap pricing when OHLC data is available. Now, what are the advantages of this type of aggregation? Significantly more efficient than close to close. Uses all available price information. Lower variance in volatility estimates. Better for short time horizons. Industry standard for volatility products. What are the disadvantages of this aggregation? Requires complete OHLC data. Assumes continuous price paths. More complex computation. Can be biased with large jumps. Not suitable for tick level analysis. Now let's get into the code. Here's my Garmin function. Um, Now, if you watch the previous video on volatility aggregation, you would know that when it comes to volatility aggregators, they're very sensitive. So you need very, very small thresholds or targets to get the threshold condition met. Now, my target right here is 0.0001 and it only has two aggregations. Now, what I'm going to do is I'm going to make this number smaller. Only a decimal point smaller and only 500 entries. And as you can see, the number of closes increased. All right. And each close is essentially this condition being met. Let's get back to the visual. Okay. Now I'm going to increase the entries to about 1,000 entries. And the thing about Garmin class volatility bars is that they're multi-dimensional aggregator, right? They take open, high, low, and close. Unlike most aggregators that we've discussed, they only use close or at most volume, right? So these are a very high dimensional aggregator. So they're far more precise than typical volatility aggregators. But let's look at the visual. Now, this is the same target, but a higher index. Now, I'm going to make the target smaller again by just a decimal point. And as you can see, there's essentially more closes being met. Now, I'm going to increase the entries. I'm going to push it to 7,000. Just to see how it looks. It's not really uniformly distributed because you can see there's periods where the close condition wasn't met. Now I want to see if I made it slightly bigger by a decimal point. Okay. This is very beautiful, very interesting. But the cool part is when you start building strategies around Garmin class volatility or imbalance bars, because there's so many cool strategies you could build. I'm not going to get into that now, obviously, but just putting it out there. Okay, I'm gonna push it to, okay, I'm not gonna take the entire data set. I'm gonna push it to about 9,000. 9,000 entries. With the same threshold, of course. Wow, this is really beautiful. Let me change the threshold. Let me make it slightly smaller. Just by a decimal point. Interesting. But that's about it for today. If you're interested in getting your hands on this market microstructure and trading systems course, plus this advanced market aggregation course, the links in the description. They're both free. You just gotta sign up for a free membership and hit the subscribe button if you want to keep up with more content like this. And I am out. Bye.